Welcome, everyone. So you are joining us right now on a sunny day. For some of you that are in Europe, we have a lot of people from Austria today. So thank you for taking time in your busy schedules to join us for this GBS Expert Talk, the third one in the series. And today we're going to look at low-tech versus high-tech solutions to envisage what are the approaches that we can have for sustainable buildings.
Hello. So also a very warm welcome from my side. My name is Barbara Meyer. I'm the organizer of the Green Building Solutions Summer University, and I'm working at the OECD Housing Office, which is a daughter company of the OECD, which is the Agency for International Exchange of Students. The OECD student housing is accommodating students, international, national students in Austria's university cities. We are a pioneer in ecological construction as we opened the first Passivhaus dorm in 2005 in Molkereistraße. And we also have 8 other energy efficient dorms throughout Austria. The latest one that was opened is in Styria, which is a part of Austria, and it's a wooden Passivhaus multi-storage building. And we also have 2 awarded buildings in the Seestadt Aspern, which is the Aspern Urban Lakeside in Vienna, the biggest urban development area in Europe. And there we have the greenhouse and the pop-up dorms. The greenhouse is the first Energy Plus student dorm, and the pop-up dorms are wooden containers in Passivhaus standard that can be moved to another place, which will actually be the case this year in summer. The Green Building Solutions is organized with the Technical University and the Boku University mainly, but we also have other academic partners all over the world. So we are working together with international and national diversity institutions and universities. It is a 3 weeks training for architects, engineers and planners, and is dealing with energy efficiency, ecological construction, Passivhaus standard, and everything that belongs to sustainable building. We also offer another summer program, which is the Alternative Economic and Monetary System, which is also taking place in July and August. This year, we are doing these 2 programs online for the second time. In general, they are taking place in person. So people come to Vienna, stay in our Passivhaus dorm throughout the 3 weeks, and they go to the university for lectures and the workshops. For this year, you can still apply until the 1st of July. So if you're interested, feel free to do so. If there are questions, feel free to get back to us. And now I hand over to Stefanie Reutmeier from the Wirtschaftsagentur. Thank you for being with us today, and enjoy the talk.
Hello, hello everyone. So it's still a bit uncommon for me to look into a screen without seeing the crowd speaking to. So yeah, but I guess that's what we will have for the next few months at least. So I'm also very happy to be one of the co-organizers of this great event today. So we have a super interesting agenda. And I just want to talk a little bit first what's my job and what I'm doing here and why I'm involved in a GBS expert talk. So I work for the Viennese business agency, and our focus is on small and medium-sized companies based in Vienna, or companies and persons wanting to move to Vienna. So we offer 360-degree service, starting from consulting and business advice to funding programs. We also help companies and persons finding the right locations for their production or their company location. And then, of course, one of the biggest points is networking. So we organize events and trying to move you forward to connect you with the right persons and partners. And so I hope this is also a chance for you today to meet some of very innovative Viennese persons and companies. And I would also point out the exhibition area where you can meet 3 different companies and look at their company profiles and also get in touch with them. And yeah, that was it, short and briefly. And I just wish you a great event.
Perfect, and thank you very much, Stephanie. So we would like to welcome, just before our first expert input, Doris Österreicher, our moderatorin for today. So Doris, if you want to say a few words just to let's say close the loop on the organization side before we have Edeltraud coming on. Are you still with us, Doris? Okay, so, well, I hope Doris will join us because the role will be important to moderate all your good questions that you're going to send us during the talks. So I would then invite Edeltraud Haselsteiner, which is actually going to present us the first input about the low-tech solutions. Edeltraud is Managing Director of Urbanity, and she's going to tell us a little bit more about her activities and the specific, let's say, insights on nature-based solutions and approaches. Edeltraud, welcome to the stage. Thank you.
Oh, hello, everybody. My name is Edeltraud Haselsteiner. I'm happy to introduce to you a few aspects about low-tech. These aspects come from a research project about low-tech architecture, where I tried, on the one hand, to select good examples of low-tech strategies, but also I tried to figure out what potentials could be in low-tech solution. So yeah, I tried to share my screen. Hopefully you can see my screen. Okay, I leave it this way.
Yes, yes, we can see it's full screen. It's perfect. Thank you.
Okay, yeah.
And people can double click on the what you are sharing to make it a little bit bigger. It's possible to just to. Thank you.
Already a company is Urbanity, which is dealing with research, not only but also mobility questions. So we try to cover a spectrum. And so why think about low-tech building? Why not just use the technology? There are some considerations. For example, construction management has become a very complex, difficult to coordinate all different specialists. So you have a lack of complete understanding of all the different expertise, and the cost efficiency. Usually, the high investment with complex building. And if you add this with the efficiency of the building, sometimes maybe it could not be in a good balance. The maintenance and adjustment aspects, as the experience if we have very specific, we need very specific to adjust the technical aspects of building. The of technical as components sometimes is much shorter than the building itself, and also an aspect is user dissatisfaction, because sometimes if technology is very much automated, yeah, people feel like they don't have individual over their own building. So this just a few aspects that lead me also about building. And we don't want only low-tech building, but we want sustainable low-tech building, which means to consider ecological, economic, and social aspects, of course. Ecological means that we have cost-saving construction, which in a broad way all existing environmental resources. We need to consider economy. In a low-tech sense, this means sufficient, robust, and cost-efficient constructions. In social, that the construction be based on the needs of the users and has to be fair also to ensure adequate supply and disposal, for example. What I add is also the aspect, because I think specifically we also need to include the people who live and use in the building. So we also have to consider simple, understandable, and self-reliant construction methods, for example. And one more, just for the theoretical background, what I think is important, if we speak about low-tech, we should not only or reduce proportion of technology in the operation phase, also in the planning and in the dismantling phase, so over the whole life cycle, we should achieve, or if we also can consider other strategies. I've collected a few arguments for like disadvantage from low tech and high tech. Go to all, but just what I think is an important difference, that of course the advantage from high tech construction is that you always will guarantee standard that does not usually not only reaches the norms and standards, but is very often above average building standards. And in low tech, you have to sufficient buildings that meets the needs, but doesn't go beyond this. It means also for comfort criteria, high-tech building, of course, you can guarantee this comfort criteria for the whole day, for example, while in low-tech building, it can be variable. So sometimes you have high temperature, low temperature. So you need more flexibility also of the users, for example. So this is one point I wanted to. Now I would like to show you a few examples. I have examples of 3 strategies. The first one, material, function, and material. Materials, you know that material different and these characteristics, if you use them ventilating, you can use material characteristics to store. You can use them to protect water, for example. You can also use material, use local, naturally growing or occurring material, your ability to reduce gray. And here you see two examples from Austria. One, the left one, is Lehmhaus Rauch. It's you can see a small construction completely built from the material, so from the excavated material, and it has mud walls outside and in. So very sophisticated construction. And on the other side, you can see an office building, 2226 now. This is a building that has very thick wall, and because of the thick walls, it's able to use this office building without any heating. There is only sensor-controlled window ventilation, and heating that is needed inside is produced by the people working there, or the computers, which are used inside. But we can also, for example, cultivate material ourselves. In this example, this is from agricultural waste, cultivated material inside the wooden construction. So this is also to produce material from waste, for example. Or we can use material that were used already to reuse material, as you can see here. The bottle houses, for example, made with glass bottles, or from plastic bottles, as you can see, for example, this Eco Park in Taipei in Expo facade was made completely by these bottles. But also a very nice example is, for example, this building from Kosovo Television. It was an old industrial building. They refurbished it completely, not so much with new material, but they used as much elements as possible from the side. For example, they cleaned all the lamps and everything that was already there, and also used a lot of materials remaining in the surrounding. For example, bricks they cleaned again for new walls in this building. Or two examples also from Vienna. For example, both of them are social businesses, so they had to be very careful with the budget, and so they used, like, for example, the last one you can see, Winzirast, used the garbage or the fruit and vegetable boxes for the walls and for the ceiling. Or the other example, Magda's Hotel and Kitchen, where they also try to reuse a lot of elements, for example, from an old hotel which was torn down. Yeah, they used the ceiling for wall decoration, but they also have a good heating concept. For example, they use the waste heat from the kitchen to heat the offices. So the second aspect is low-tech to support functioning, for example, for heating, ventilation, cooling, or exposure. It's quite well known that so we can gain heat, of course, from solar, from the sun, but we can also use the wind, natural ventilation. We can use temperature either from the air or from the soil for heating and cooling. We can use the microclimate close to the building, for example, if we have water for cooling, if we have trees for cooling, and or we have wind. But it also, we just can consider to as much as possible, and not Yeah, this is and now and all the one of the first examples architecture. You can see that from Robert a Swiss, he tried to the facade as much as possible to the sun and have more you can from where he can store is an example how to optimize. Or this example, the church in Senegal, where they took example from these termite buildings and combined this with the system of natural ventilation, which is just working on thermal effects that warm heat is going up, and so they have ventilation just by the way how it's built. Or another example also from Austria, from Vienna, this energy facade, which is folded to radiation, but also they use these plants you can see on one of the photos for climate and have the third aspect, system construction. I think in many constructions, the construction material is used always on the safe side. So I think it also a lot to minimize the material quantity to a minimum. So always to prove is it possible to have this thickness of materials, for example, but also to how is it possible to reduce complexity, for example, not use too many different materials so that you can extend the lifetime of building. The way you connect the material is, of course, also very important in case of dismantling or repair. And the last aspect is also to error-prone, less error-prone building structure, so that you can ensure less maintenance costs, for example. I have selected here only for the aspect of fabrication a few examples. For example, you can see here this system from a Spanish architect. You can see very simply to assemble. It's more or less like an IKEA meuble put together without any problem. And up, that's the wrong side. And here, just another few example of modular system. The left one is a modular system from Lucas Lang. He has designed a construction kit of a lot of flexible small-scale components, and these were put together on the site after for temporary building. It's very easy to put together, but also to dismantle again after use and just construct again. Or two other examples, the one is with steel, concrete, and timber, a timber construction. You also can see very simple construction that can be easily, or the slim profile from the right, where you also can see they tried to use as less material as possible, and combined with ceiling, it gives a very efficient structure. So just a few concluding remarks. I think it's important to critically question the cost of high-tech building over the whole life cycle, to question also our what are our basic needs and what is already beyond. So I think we can experience this in different different life. If we see, for example, our mobile phone, they have a lot of functioning, but in real, we only use very few of them. And this is, I think, a strategy we also should have demand or questioning also in our building or constructions. Low tech, I would say it's a method to optimize building. Of course, it's clearly we need technology. It's not no tech, it's low tech. So for me, it's a strategy to help our constructions to be optimized also in an environmental sense. I think that low-tech strategies enable users to reconnect more closely with nature if we really include nature-based solutions, for example. And low-tech could also be a strategy to raise more the individual responsibility and identification of the users. And this low we should have an openness for experiments. So that's from you very much for your attention, and here you can find the about research project. Yeah, so yeah, looking forward to the question.
Thank you, Edeltraud. So really appreciate the input. We were a little bit provocative just to provoke the discussion in the title, low tech versus high tech. Of course, this is not such a clear line because it's really a combination. And I like what you mentioned about the connection with nature and identifying what we need as occupiers also of buildings and as people, and to reconnect this with the method of how we think about buildings and the spaces around them. So really appreciated that. I would like to present you. So Stephanie mentioned we have an exposition section, so an expo where we have 3 companies which have prepared videos just for you to introduce, you know, their services or the ideas around the topic. And what I will do now is present you one of those videos. Just let me copy it right here. And yeah, so about capital A architects. So enjoy this little video intermade, and we come back later. Excellent. Thank you very much. And very much enjoyed the video. Let me see how I can stop sharing something here. In any case, I would like to introduce you to Doris Österreicher, who is going to be moderating our discussion after the two expert inputs. So please, Doris, join me on stage. By the way, there's other two very interesting videos that have been produced just on the topic for you today. So when we're done, after the second input, please head to the Expo or Ausstellung icon on your left-hand side, and you will see some nice alternative materials presented there and alternative methods for construction. So we have M-Static and Schöbel and Paul that have did something special for you. So head out there in the end as well. Thank you. So Doris, please join us.
Yes, now it seems to work. Thank you. So welcome also from my side. I'm happy to moderate this session this afternoon on low-tech versus high-tech. And Dominic has already said it's not really versus, it's more, maybe it should go combined. And I would like to introduce our second speaker for today, Thomas Gampel from Wiesmann Group. And he will present a talk on ice storage systems, heat pumps combined with solar energy and innovative exergetic storage. So welcome, Thomas, and the floor is yours. And after that, we will come back and have a lively discussions on the pros and cons on low-tech versus high-tech. So, yes, very good. Welcome.
Hi, Doris. Thank you for your introduction. I would like to introduce myself. My name is Thomas Gampel, sales engineer from Wiesmann Group in Austria. I'm responsible for the larger heat pumps for multivalent heating systems and cooling systems. And I also provide the bigger automatic systems to combine sources for heat pumps in buildings like economy, storages like buildings for living spaces and quarters. And this is where we find a lot of sources to use for the heat pumps. And I would like to introduce you to ice storage systems. So let's begin. So I guess you can see the presentation.
Confirmed.
Yeah, nice.
Received, Roger.
Perfect. Yeah, I don't know who of you or how many of you have ever heard about the ice storage systems. So I would like to start over with some heat pumps basics, like what do we understand for heat pumps and the sources. Some requirements on the heat pumps are like integration of some renewable energy systems, and for the future, of course, the managing the electricity in smart grids and its implementation for heat pumps, like not only the single sources for heating and cooling and hot water, it also should integrate as a key position in the power independent system for the future. So we all know some key sources of heat pumps, like the ground collectors in the earth, in the soil, the borehole heat exchanger, the two-well array with water heat pumps, and of course the air as a source. Yeah, we all know the advantages and disadvantages of each of the sources, and yeah, some main differences and players who match on the field, on the building sector is like, okay, we invest in some ground sources heat pumps, and you know the advantages. You won't see any fans on the rooftop. You have no noise around, and you need the invest cost for the source. Yeah, this is mainly the battle between these two technologies and sources. That's I do and see and hear every day in my daily work. And so we have the idea to combine a lot of sources and win the sources as source for the heat pump. Here we got the each source and combined this to the energy storage, and from the energy storage and the piping and the hydraulics and the automatics should use the best available source for the heat pump. This should be the outcome. Yeah. The first point was also here the cooling, energy from room cooling processes or production processes. It's pretty hard in the future to neglect the cooling processes. They will rise and rise in its amount, and we need to use them as a heat source. So the ice storage system, we won a lot of innovation prizes and environmental prizes. At last, I knew the IKEA project. We won 2020 the Solar Prize in Austria, and some other projects also in Austria where we won some prizes. And in Europe, there's a lot of, how should I say, welcomeness to this new, not new, but friendly, environmental friendly technology. Yeah, the principle of the ice energy storage system. We save energy, like energetic energy, in a low temperature level. So there is no big use of insulation for the system. We want to use the energy from the ground. So there's a deep storage of, from concrete in the from 2 to minus 8 or 7 meters underneath the earth, underneath a parking lot or a garage. And so we use the energy which comes from the earth as the first part. And we use the temperature from 0 degrees to 25 degrees, for example, as an input to the heat pump. It's a ice storage. The concrete storage is filled with water, and this water is due to the evaporating process of the heat pump. We turn it into ice, and this part, or this energy which we get from the crystallization is a lot of energy, and that's why this volume of the storages brings us a lot of source energy. Yeah, not at least the cooling capacity of the ice is used during nearly the whole a lot of the cooling season. We use it as free cooling. For example, my projects reach natural cooling without heat pump energy till August, till end of August, maybe till July, and this is absolute amazing. So that's the reverse process we use from melting the ice to water, and it's like the same energy from 1 kilogram of ice going into water is like boiling it up from 0 degrees to 80 degrees, and this is about 360 joules kilojoules we use here. So this is a sketch here of what parts are included in such an ice storage system. I told you we got the solar prize in Austria 2020. So it's not only the ice storage which we use, and as you can see here in the numbers, we not only use the earth as a energy winner to the ice storage. We also use, and this you can see in the numbers, from the collector of the on top of the rooftop of the building. The sun and the air is a big player in the source system. So we win more energy from the sun as we win from the ice storage, and these energies will go to the heat pump, and we delivers the energy to the building as a heating. And you can see here that there's a lot of natural cooling potential. For example, for my buildings projected, it was like 10 to 15, nearly 20% of natural cooling capacity to the active cooling. Depends on the using of the building, of course, and what the power of heating and cooling is. So the main part is the solar system. We have several types of how to collect the air, the energy of the air, and the energy of the sun. We use these solar systems till -4 degrees of air temperature, outside air temperature, because there's also still a not only energy in the air, but there is also solar input that we can use. Yeah, we use it as a source for the heat pump, which works till 20 degrees of income to the evaporator. So there is a lot of use in the time of the solar systems we use here. There's not a high efficiency solar system for the solar panels. They are kindly of PE materials, aluminium with a special coating, and there is some lack of solar and low or medium air temperature, so that in that cases there is, like, depending on the location of the building or the energy system, we got 2 to 3 weeks in a year or maybe 10 days in a row we can't use the energy system of the solars. So we need to get the energy system or the source from the cooling of the building mainly, and as a second step we use the ice storage. So here you see a solar capacity from the rooftop. We use the water in here as a source for the heat pump. And there's some points of date where we use and invest in a lower temperature for the evaporator side of the heat pump when we want to produce ice. The ice is used, we need to heat anyway, and we risk a little bit lack of lower COP for the heat pump to produce the ice for the cooling. Cooling is also important important source, and so we use it for the cooling. As a practical project, I would like to present you the IKEA CDC. This is the customer logistics center from IKEA Austria. They store there all the things you will order on IKEA, and they will be stored in the 21st district of Vienna. And there we were able to build in a ice storage with heat pumps, and I would like to introduce you to this system. So we got a ice storage with 90 meter in the diameter, 6 meter height. got a capacity of 1,700 square meter. We built in there 23 kilometers of heat exchanger pipes, and we assembled 127 collectors, solar collectors, which we serve the evaporating side of the heat pump. So these collectors are used to deliver energy for 1 megawatt of heating system to the heat pump. And as you can see, the numbers of the energies, you see that there's a lot of nearly three times more than from the ice storage, and what the energy of the heat pump, the electrical heat pump drive is. So we get a CER from 4.4. Here's the ice storage in the beginning, in the erection, where we dig out the hole and then build in the concrete within the heat pipes, the pipes for the heat exchanger. We do this for projects from 30 kilowatt upwards, like to 5 megawatts. So we can project it for your project and try to use the controls for the heat pumps to use nearly every source we can get. So there are 3 heat pumps in this system. The project got 50,000 square meters in heating or heated area of the building. There are 2 heat pumps which are provided from the ice storage system and the solar panels, and there's 1 heat pump from the water system from the farewell. And you can see afterwards in these links the solar prices, and here is some from the Buildings Times article. Another project I would like to introduce you is audio tuning project. It's a market leader in high-end hi-fi audio. They make the vinyl players and ship them worldwide, and they decided to make it low-tech, high-tech, available and produce low energy. So you can see a picture of the solar collectors we used there in that project. We already certificated is on the Solar Keymark platform. So the great part of these systems are we can get a lot of funding from the solar energy. We get funding for special and innovative storage systems, and yeah, we get a good control over the making the ice using other wells and sources for the heat pumps. And there's a lot of how should I say, possibilities in the controls. The control is key fact. We monitor the systems, the storage, the sources for the heat pumps, and we're triggering back and we're triggering forward to optimize the system for the user. We trigger it to the customers using of the building, and that's the key fact. Yeah, monitoring. So here's a energy chart of the audio tuning project. As you can see, overall over the season, they also installed a photovoltaic system, which we also can combine with heat pumps and with the solar system, with the water-filled solar system. And on the balancing part, we used 8.9 megawatt hours of energy for the heating system, where we delivered nearly 300 megawatt hours of heating and cooling capacity. So I would like to thank you for your attention, and I'm happy to hear from your questions.
Well, thank you very much, Thomas, for this really interesting talk on ice storage. I think that's a good kind of opposite to the low-tech solutions that we have already heard. And I would like now to also ask Edeltraud to come online again so that we can actually start the discussion. Yes, very good. Hi, good to see you again. And Dominic is here as well.
Yes, I'm just there.
That?
Yeah, I'm just there. Thank you again for the input from both sides. I think complementary input as well. I'm just here, and I would encourage again the people to ask their questions. I'm going to be sharing the top questions directly on the screen here. So just head to Slido and ask the questions. I have one maybe to kick it off already. To Thomas. So it seems that it was not just a single system that is envisaged. It seems to be a strategy expanding, adding photovoltaics and so on. Is this kind of an open-ended project where they want to really, let's say, invest further? Or was this kind of, that was it with what we've seen, what you presented?
Like the customers, or is it for the whole system as we follow up? So as we follow up, we try to use processes for the source. We want to use photovoltaic as source for the heat pump. We try to collect as many sources as we get, and for the customers I presented, like audio tuning or IKEA, they try to invest in more solar systems. That was, I think, the key message. They saw that solar systems is key, or brings a lot of energy to their footprint.
Okay.
Thank you.
Dominic, do you want to continue, or
no, it's all yours now.
Okay.
I hope you see the questions.
Yes, good. And we have time until we have a bit of time to discuss this all. So thanks again. I would also like to, before we go into the question, to start off with maybe 2 comments that you can make. I was looking through recently through an IEA report, so the International Energy Agency, and they are basically saying in 2050, almost half of the reduction in emissions will come from technologies that are not yet out there, or that are just at a prototype stage. So maybe just to kick off the whole discussion here, before I go into all your questions that you have on the Slido, maybe can I both ask you to give a short statement to that? So do you think that this is, this is what's going to happen, that for now we have the technologies that we'll be using until 2050, but then we need other technologies that are only at the innovative stage yet, at the prototype stage? Maybe Edeltraud, I want to kick off with you, and then move on to Thomas.
Yeah, maybe I can argue with another argument, specifically, for example, in mobility. Maybe we can find new technologies which are even more efficient than the ones we have now. But for example, in mobility, we know already that electric mobility will not solve our problem to reach the climate goals. Yeah, so this means we also need to change our habits. Yeah, not only technology. Yeah. And that's what I think is will help us much. Or that's my opinion. I think that we need a change in also social innovations to really reach the climate goals, and not only technology be the solution.
So we need to do something as well, we as people.
Yes.
Okay, Thomas, what's your view on that?
I agree with Edeltraud. Like habits is also a key factor of winning the CO2 war or the pollution war. There is a lot of energy loss and energy that is used in things that we, but it's political and social, I guess. But yeah, there needs to get we are not on the top of the technology, I guess, and there will be a development in 20 years or in 30 years. We are doing the work and work on newer technologies. Like I saw the news a few days ago. We started a oxygen, but on a water fueled boiler. What is it? H like Wasserstoff boiler for steam. Yeah, so there's also in the mobility a large step to make, and in the industrial sector for high processed or high temperature processes, which are producing the daily needs of everyone. And yeah, you can steer it through habits, or in 20, 30 years, I hope there will be better technologies to solve these problems.
Okay, or maybe a combination of both. So I would like to go to the questions now that I see on Slido. So maybe we start off with the scaling up. I think there were questions both for Thomas and Edeltraud regarding the scaling up and the application of nature-based solutions and technologies. So maybe Edeltraud, you can answer the first one. Is it easy to scale up projects which are nature-based? So when we talk about scale-up, I would have thought, it's not just a single-family home, but talking about larger residential offices or homes, larger offices, or maybe even a university or larger entities. What do you think in that respect?
Yeah, I think in this case, it's the question, do we need to scale up or do we need individual specific solutions? For example, maybe for office building, I will need other solutions maybe than I use for single family houses. And so also the concept has to be different, because in office building, I know the people use during daytime. In small family houses, I know they need it or use it mainly maybe in the evening or in the nighttime. So you have to differ between comfort criteria, for example. But so for me, it's not so much the question about scale up, but the question about specific solution, and to have a solution that really fit to the needs.
Mm-hmm. So application, really focusing on the application as such.
Yes. Yeah.
Okay. Thanks. And I have another question for Thomas, which was in the slide or before, because it fits to the scale up. And people are asking if for what sort of type and size of building is an ice storage system suitable? Is it also suitable for offices and other buildings, or is it only for large scale buildings? Because you mentioned before, I think, from 30 kilowatts onwards to 5 megawatts. So it seems like it's applicable to a wide range of buildings. Can I use it in a single family house?
Yes, good question. Yes, we got systems from 6 to 12 kilowatts also. So there are finished systems for kind of plugged in or plug and play systems we can deliver to family houses as well. There's such the diversity or the individuality raises up with bigger buildings and industrial, such offices or industrial buildings. But it's also used in home systems and family houses, yes.
Now I just have a follow-up question. How much space does that take then?
That's a good question. It depends hard on the users, on the user experience and the use of the building. because when there is the whole year a lot of cooling capacity, you won't need any source for the heating system, because there's a lot of source. And this is this question I get asked every time at the beginning: how many cubic meters do we need? And they say, deliver me the numbers of your heating and cooling capacities, and I will tell you. And that's when they start to think over the system. Yeah, it depends on the system. For like 50 kilowatts, there's like 100 to 150 cubic meters. For the home systems, we got like plug and play systems with 8 to 10 cubic meters. So it's a kind of escalation, but it needs to get projected.
So a few bathtubs full
Yeah.
of ice. Okay, just a very loose translation of this. Maybe coming back to the low-tech solutions, there's a question: should the ecological cost of technology be included in the selling price? So kind of what we're thinking about this CO2 emission tax, I guess. Would that make low impact on nature-based solutions more attractive? Edeltraud, maybe a question to you, or actually then to both of you, but maybe we start with you. Do you think that should be sort of factored in, like with a tax or with some other system?
Yes, I think definitely yes. Yeah, because, for example, also for a lot of material, you have a lot of transportation costs, for example, which are really not included in the actual cost. Yeah. So if we have more, how to say, if the price is really also including all the environmental costs, yeah, that go along with these products, then I think we would have the people have to think more about what they buy, yeah, because then the costs are much higher. So the question is, yeah, do I really need this product, yeah, or may I also use the product that is growing just next to me? Yeah, so definitely yes, yeah.
Thomas, what's your take on that? When you look at emission taxes, I mean, for the business that you're in, would that support your business or would it hinder it?
No, it would definitely support it. We have a positive outcome over the lifetime of the building, and this is where the investors are asked to, and this is where CO2 labels for buildings should fix in and clear this problem, I guess.
Yeah. So again, it's not low tech versus high tech. So
no,
it's again
it's always
the combination of both. I'm looking at another question, which I think is quite interesting, which always comes up when it comes to nature-based solution, Edeltraud. Can the durability and lifetime of materials like agricultural waste, how does it compare to other sort of materials? Because I guess that's what sort of the typical developer is interested in. When we implement some nature-based solution, now let's think about maybe insulation materials or other sort of materials that is not so common in typical construction business, as opposed to concrete and brick and stuff. How do you convince them, and how can you tell them what about that durability? Will that still be as durable as it is now, as it is in 20, 30, 40 years to come?
Yeah, I think just we can take the example of wood, for example. Yeah, I don't know how much or how long is the lifetime, for example, of a wooden construction compared to a concrete construction. Yeah, so of course it depends on which material you choose. Yeah. And but I think with this material we have already a lot of experience. So I think in general we know about the durability and about the lifetime of this material. So we have much more experience with this material than we have, for example, with electronic components. Yeah? Where very often we do not know how long they will last or when we have to exchange them again.
Yeah. So I moved the question over to Thomas, even if it's not asked in Slido. What about the systems, like these sort of innovative systems that you have been promoting today, like ice storage? Is that a lasting thing? Does it need maintenance? Is it there? Is it still to be there in 30, 40, 50 years' time?
We got this technology, like ice storage was common before the fossil fuel was famous, like 100, 120 years ago. We tried to use safe energy on this level and used ice, like the heat pump system 100 years ago. Our systems, our patented system is like 22 years old. So we built the systems like for this time, and the maintenance of the system is pretty low. Like you have like a borehole for water heat pumps or Sol heat pumps. There you won't know what's underneath 100 meters. Yeah, you have no influence on it. The soil is moving. The soil is could destroy some boreholes, and there's where my argument is like, okay, you have a storage underneath the earth, but you can get in it and you can repair it. So this is argument or advantage on our system. But yeah, there's it should at least have a lifetime of the building, and the materials we use are like lifetime sentence from 30 to 50 years, maybe 60 years. And of course, there's a maintenance on the solar panels. There is not a moving part in it, but the heat and cold transmission on it, there could be some leakage here and then. Yeah, so like you need to maintain the pipes. Yeah.
Yeah. So also in high tech, you mentioned that just there is no moving parts. I think that's an important issue always. You know, if you have sort of high maintenance aspects, or if it's innovative systems but with low maintenance, which you're just describing. And I think that's a very important aspect. So you can be innovative, but it doesn't need to be high maintenance.
Yeah.
Okay, thanks. I'm moving on to another question. I think that's more of a sort of almost a philosophical question. How can we promote low-tech nature-based solutions when there is excessive focus on digitalization and other tech solutions? So maybe let me rephrase the question. Can nature-based solutions go hand in hand with digitalization, and how? So to Edeltraud, this question.
Yeah, yes, difficult question. I hope, yes. Because of course there is not really a lobby, I would say, for low-tech and nature-based solution, or the lobby is, I would say, rather low, because there's not really an industry behind this kind of solutions. But I can see that that interest is growing. For example, in Austria, we have a new research research strategy about circular economy. And I think specifically in circular economy, you also need to develop or it's not only about the economy, but it's also about circular solutions. And this could be, this for me is also very important in low tech, that you're looking for synergies, you're looking for circles, resource circles, for example. So this is where I see the possibility for low tech aspects. But yes, yeah, I hope that also we have at least these two strengths, not only digitalization and the high technological solutions, but we also look for nature-based solutions.
Yeah. So let me take that question and that point that you made about the circular economy. And I want to ask Thomas about this, because every time when we're talking about high-tech systems and innovative solutions, then mostly the question comes up with, what about the materials that you put in? How can you, where do you source your materials from? Is that sort of a sustainable source, or the raw materials that you're using? And at the end of the lifetime of your product, can it be taken apart? Can it be recycled? Can it be part of a circular economy?
That's not easy question. We use materials like pipes out of artificial materials. We use metals, of course. I think that we won't have that positive impact in that case. But of course, we can recycle it. I think the materials are used which could be used in any further operations and buildings and erectings and processes.
Okay. So I guess taking things apart, I think that's what we're always advocating, not thinking about different aspects of putting things together, not just gluing, but maybe also screwing things together so that they can be taken apart at the end of the life cycle. So I guess these are thoughts that are also very common in the industry today, thinking about circular economy.
Of course, yeah. Of course. So dismantling is a big part. I learned from it also in some professions, and dismantling in each or in every industry is a key part of end of the lifetime, and people get aware of it and need to get aware of it.
Yeah. Let me move on to another question, which I'm not sure if that's how we can implement this at the moment, but it's a very timely question. So there's always a talk now with COVID-19 about air quality in buildings, in terms of thermal comfort or in terms of providing air ventilation in buildings by mechanical ventilation or natural ventilation. What are your thoughts on this? Has the industry been moving on in that respect? I mean, are we actually changing things now because we understand much more about what a virus can do to us and how to contaminate it? Or is it just we're using the systems that have been there all along? Maybe I start with Thomas. In this respect, what are your thoughts on this?
I think Viessmann is in its position as a leading company for heating and climate systems, also responsible for bringing some technologies and making technologies available. Like we used some spaces of a production lot to produce ventilating masks for hospitality, and on the other hand we made a ventilating system for schools. There is a big topic on schools, like the kids need to sit with masks or need to get in partial learning or distance learning, and we innovated some ventilating system which cleans the air for like sizes for typically classes. We provided some schools with it. We made some tests, and we try to make them available for more and more people. It's also usable in offices, in buildings, so we do our part, I think, and we go on with it.
But do you think, just as a follow-up, do you think there is now a higher demand based on COVID-19 on mechanical ventilation systems? Can you see that in the market?
I guess so, yeah.
Yeah, okay.
Yeah.
Okay, let me move on to Edeltraud. What do you think about these aspects? COVID-19, when we talk about mechanical ventilation, as Thomas has just noted, in school buildings where we need mechanical ventilation due to the high air change rates, if we don't want to lose the energy sort of with opening the windows. Can we still follow up with nature-based solutions, or just do out without mechanical ventilation, which is natural ventilation? even if we have now this sort of aspects of viruses and other things. What are your thoughts on this?
Yeah, I'm not so much, I'm not experienced with ventilation system and how efficient they are compared with natural ventilation. But it's just like my personal feeling. If I open windows on the one and on the other side, yeah, and there is a good breeze, so I would say that also the ventilation could be as effective as mechanical ventilation. But on the other hand, I understand that we have a growing demand on comfort criteria, like I think 20, 50 years ago, yeah, we didn't expect to have the same temperature the whole day or during the whole year, but we were much more tolerant against different temperatures during the year and adapt ourselves to these different temperatures. Now we lost this kind of tolerance. So I think that's, I come back to the first question. I think we also need to think about our habits or our demands to reflect this a little bit more, what we really need, or if it wouldn't also be possible to find easy other solution, not only technical.
So dress appropriately, so to
For
speak,
example.
as well. Which is an easy solution that every one of us can do. Okay, before we come to the last questions, maybe one more for Thomas. I think there is a question about, are there any projects coming up for storage systems in office or residential buildings? I think it has to do with, can you share some pilot projects or other stories about your upcoming projects?
Yeah, of course. We're just erecting a system for a how can I say office which industry which produces salads. Yeah, they are making vegetable salads. They are making them for convenience food and for some supermarket systems, and there we provide our system for cooling and heating the processes. They got a lot of demand of cooling the water and heating the ventilation systems. It's quite big. It's nearly half the size of IKEA, and it has a lot of. It's heavy to control the whole system because it's such a heavy process for heat pumps and for the system as general. Will be a nice project. There are coming up projects in residential areas as well, and I hope to find some residential projects. I would like to find some Viennese projects with ice storage and for residential. I got a kindergarten in Vienna provided with the ice storage system. There's some places and spaces which ice storage fits perfectly. Like there's no gas in the area. There's no district heating available. It's a residential quarter where you can't heat with air water heat pumps or with biomass. So with the restricted area, and that was a question before, with the restricted area, you can build the storage underneath nearly the building, underneath the parking lot, in the garden, underneath a tree.
Yeah, so I think that's a very important aspect when we talk about Vienna. Vienna wants to get rid of gas or rid of fossil fuels at the end of the day. So I think that's very important.
Yeah, I got a elderly dorm we erect and we are projecting. There's also, they used some boreholes for the heat pump, and after 20 years they saw that the boreholes wasn't that efficiency anymore. They lost their power, and so we are adapting it to an ice storage system.
Okay. Well, thanks. That's nice of you to share also sort of the project ideas. I left one last question for the end because I think it's a nice kind of closing questions, and we have about 5 minutes left. And it is about what are your feeling about actual trends? Are we going back to more natural built environments, or is it smart homes and new technologies all over? What do you think? Where's the market going? So maybe both of you, I would like to ask for a short sort of closing statement about where are we in 20, 30 years time and how we'll be living then. Maybe Edeltraud, do you want to start with your closing argument on this?
Yeah, good question. I hope that COVID-19 changed a little bit our awareness about nature and about our surrounding. Yeah, because I think we relied a lot about our small parks, about our forest very close, yeah? And also to get to how can I say, to find again how nice it is just to make a walk, yeah, and have all this nature around us. So that's what I hope. That at least gives nature-based solutions or this trend the same status than we have already for technical solutions.
So you think, will there be more, let's say, just as a last follow-up question on the building industry, do you think there will be a move towards more nature-based solution due to the pandemic? Do you think that's sort of a direction that this is going?
I could I would assume that this could be, yes, because of the pandemic. Yeah, the people are more aware now about nature, and then also maybe about nature-based solution. And maybe also we need so much this because we have now all these online conferences and we have all this digitalization. So maybe we also like also to have an alternative and just make a walk in the nature and appreciate this more. Yeah, I would say.
Okay, thanks a lot. That's a nice closing argument. Appreciate nature as well, what we see around us. Thank you. Thomas, your last point on this. Where do you see the trends? What's your feeling? Are we all digitalized in 20, 30 years and we have our kind of screen full of forests rather than a real forest outside? What do you think? And what does it mean for the building industry in your point of view?
I think the political goals are clear. I think they need to be on a goal stadium. So the technology will raise. Yeah, there will be a lot more density of digitalization and technology, but we need to raise also the efficiency in building systems, the efficiency in the energy loss. And there will be, like Edeltraud said before, the social habits and social innovations are also a main part, because mobility with 30% of the energy usage of the country or the world is a big part, and there's a technology to get used to lower it, or the habits, and it's a hard topic. I hope the best.
Well, thank you very much. I think you tackled the question well, because it is a difficult question. We don't really know where we're going. And I think what the discussion shows, it relies a lot on us as well, us as humans, how we change our behavior or how we adapt our behavior. Where do we want to change? Where do we keep our habits, being them good or bad habits? And technology can support us, but we need the nature as well. So I think that's a nice closing argument from both of you, that it's just the synergies, I guess, from both worlds that will help us to tackle this topic. So I think we're really on time. I am now looking for Dominic, because
Yes,
I think
I
you
am.
still have a networking question.
Yeah,
It
yeah,
remains for
I'm.
me to say thank you to
Yeah.
both of you for this really nice discussion and your presentations. And it was a pleasure to be the moderator for you both and for the audience today. Thank you.
Thank you, Doris.
Thank you, Doris, and thank you to both of you for your inputs as well. Yeah, I like this this kind of. We started with verses, but at the end, it's more like hand in hand that we need to consider, and the complementarity of the world we live in is calling for those solutions from all sides, and everything that we have at our disposal to overcome these challenges, to decarbonize the sectors for the future buildings, but cities as well. So we saw this also in the bigger context, which I appreciated as well, the input.